Recording. Hello everyone and welcome back to Handmade Hero, the show where we code a complete game live on stream. Although we have not been coding for 2 weeks. We had 2 weeks off because I was out of the country and unable to actually do any sort of streaming, so that that pretty much meant the show was down. But we are back now and we are trying to wrap up our debug system. That's what we sort of stopped on. And we still have a few more things left to do in that, so I would like to sort of get into doing them. Now, it's always kind of tricky, obviously, when you come back after taking a while off from the code. You know, your brain can kind of sort of forget what it was working on or forget what's going on. So people were asking in the pre-stream about that and wondering a little bit about that. And like I was sort of saying there, and it bears repeating, generally what I do for this sort of a thing is I tend to try and keep my code base very consistent. Like what I try to do with code is I try to, sort of make, I try to make general rules about how I do stuff, and you see me oftentimes type in things. They sort of look the same and follow the same sort of structure in general when I'm writing code. That is there for a number of reasons, and one big one is that the more consistent you are with the way that you choose to make things work, the less difficult it is for you to, to guess what code does if you've forgotten, right? So if I see a function and it's named a particular way and it takes a certain parameters in a certain order, all of those things are like clues to me about how that function probably was implemented. And the closer you can stay to having consistency in the code that works that way, the less you have to remember about your code base, right? And so there's no way to do that perfectly, right? You can't really eliminate all surprises. If you work on enough code and you make enough code, which I definitely do, you will forget stuff, and you will forget some important things, and you will get bugs because you forgot something, and that's just the nature of the beast, and it's nothing to be worried about. But you do want to try to minimize that sort of thing, because just in general, even from day-to-day coding, it tends to be pretty valuable to sort of have an expectation about what code does, and to have that expectation usually be correct. It just saves a lot of mental energy, and it prevents a lot of bugs that might happen. It's just a nice thing. So let's just take a quick look at where we sort of left off. And you can see we've got our sort of game all running here. And if I remember correctly, we sort of turned the debug system off just to leave everything in a state where anyone who wanted to play around with it, since we hadn't quite finished it yet, could play around with it and be fine with that. So what we want to do first is turn the debug system back on. And we sort of have this debug. We just at the end, we sort of pulled it back out. The debug system all kind of exists in here, right? And we've got some pound defines which turn it on and off. You can see that here's the one that actually turned it off. So if I do that, we can turn it back on again. And now we're building, but I suspect we eventually crash or something like this, I would think. Yeah, there we go. And so what I believe we stopped, if I remember correctly, where we actually stopped, was that we were processing frames now. We were actually processing them fully incrementally, but we had not actually gotten to the point where we freed everything. So we would get to a circumstance where we were building up frames incrementally, but then nobody would ever actually free any memory taken up by those frames. So eventually you get enough frames in the debug buffer, and you're going to run out of arena space, right? And that's exactly what that was right here, right? You can see we're just running along, it's collecting debug events and doing whatever else it's going to do. And then you end up in a situation like you see here, where it's like, okay, we've sort of run out of the memory that we had to work with. Now, one thing that's a little troubling to me, and I'm not really sure, I guess, okay, so it's not actually, I suppose it's not actually necessarily troubling to me, but it's just a little weird. I have to think about this. You can see that this last frame time here looks kind of weird and garbagey. So I'm kind of interested to know, I guess we'll see when I actually go through and finish this up, we'll see what's actually going on there. But that's just a little weird to me, because you can tell the frame rate, if the frame time was actually 300 milliseconds, that would imply, you know, somewhere between 3 and 4 frames a second, right? If I'm doing that right. So 3 or 4 frames a second, this is running way too fast for that. That's way faster than 3 frames a second. So that's wrong. Now, it may just be displaying only the first frame, and maybe the first frame took longer for various reasons, but I'm just saying, like, anytime I see something like that, I get a little bit nervous. So I'm just going to put that in the back of everyone's mind as something that shouldn't have been what it was. And so when we sort of finish doing this, if we're still seeing that, that probably is something that warrants investigation. All right, so let's go ahead and jump back. I think we left even some to-dos in here for ourselves, which mentioned about sort of the freeing. You can kind of see here, like, okay, like we don't even have this free variable group stuff implemented. So if I remember correctly, basically what we want to do is take this like free frame thing, and we want to sort of make this actually, A, actually work, and B, actually be called. Because I suspect, if I remember where we were at, I suspect we don't actually ever really call that. And I'm looking through here, and I'm seeing that I'm correct about that. Because this right here, all this is the time when, if you were paused, it will throw out the latest frames so that they don't take up any space, don't do anything. But if you think about it, when you do, if that's the only time that they're getting freed, then there's no time when we're actually freeing the frames in sort of that circular, in that rolling buffer, right? There's no time when we're actually doing any sort of freeing of the frames that are building up, which is what we want to do, right? Like, we want to free frames as they build up so that we don't run out of that memory. So those are the two things we need to do. We need to call free frame at the right times, and we need to have it actually do the freeing. So this, for example, needs to happen. All right. So, and you can see we've got two to-dos here as well. All right, so that's what we've got to do. And we also have a to-do here that says remember to copy out the debug events into the debug variable links. And what that was talking about, this again, I guess so. Despite what I said, I guess what I'm sort of actually seeing here as I'm discussing this is, I guess my memory for the code actually is pretty good. I remember all this stuff, so I don't know. I guess 2 weeks is not long enough for me to have paged it out, which I suppose is a little bit surprising to me at my age, but I don't know. I guess maybe I'm just getting lucky. Who knows? Anyway, point being, if you remember how the system worked, at the end what we decided to do as we sort of started boiling it down, and like I said, we were kind of going through this period of like simplifying things, kind of getting them a little more sort of straightforward, usable, and a little more better structured and not so sprawling. What we did here is we took the debug table and we had all the events that were being recorded. We used to have like all the frames would just sort of sit there in those event arrays. So as you sort of streamed out into the event arrays were actually where the source data was. Then we had the collators that would kind of run on that. It was kind of this all big proliferation of stuff. So what we did at the very end there is we just reduced it down to just 2 buffers. So basically, the game code, all the code, I should say, the non-debug code, is writing into one of those event buffers while we are using the other event buffer, right? So it's just a straight ping pong buffer scheme. Only 2 buffers. There's one that's being written to and one that's being read from at any given time, then that's it. And what that means is that as we are preserving those events for later viewing in the debug system, we end up in a scenario where those debug events themselves cannot actually be used out of these buffers anymore. Because as soon as you're more than 1 frame back, if you're looking at 4 frames back, 5 frames back, the events are gone, right? So when we do the collation, we actually have to move the debug event out of here and into the actual permanent storage of those debug variables that we had, right? So that the actual sort of collation step needs to actually store the debug event, where, as I think, if I'm not mistaken, the way that this works at the moment is it actually just references that debug event directly. So if you take a look at this code here, right? if you take a look at this code here, what you can see is that we have sort of these debug variable links, that sort of thing, and the debug variable link just points to a particular debug event, right? And that's not actually necessarily bad, because we probably want to continue doing that since the debug event is the piece of actual data, right, that we're trying to keep there or whatever. But the thing about that is that this debug variable link is, there could be multiple of those that are all sort of pointing to the same piece of data, right? Because if we have that thing where we can pull off piece of the UI, we sort of did that stuff before. All of those pieces of the UI might want to point at the same piece of data, and so it's not necessarily bad that it's a pointer, right? Because we could just go like that and embed the data in. So it's not necessarily bad that it's a pointer, but if we do in fact keep it as a pointer, we need to at least make space for wherever that debug event actually is supposed to go, right? And so there's that. So I don't know. Again, that's the sort of thing that we're, I don't know, I want to say sort of wrestling with here. That's the sort of part that we're kind of going back and forth on. We know that these debug variable links will all sort of are things that kind of get allocated, and we know that we have these sort of standing structures there. We know that we have debug events that are kind of getting written out, and then we were sort of pointing at those as actual data. And then we also have this kind of concept of the collation step that runs over things and sort of tries to line up events with other events and do other sorts of stuff like that. And again, it's a very complex system, and it's been sort of a winnowing process of figuring out how those things have to sort of come together. And so it really is just a sort of, it really is a kind of difficult thing to sort of understand or sort of to know exactly what the right thing is to do, because again, if you also look at sort of the way that this debug frame stuff works, it's tempting to say that the way that we were doing it before is actually how you might want to do it. Like it's tempting to say, well, okay, could we not just make a giant circular buffer of the debug events, so the debug events all kind of go into that buffer, right? And then we just point back at them directly. The reason that I'm trending away from that is because when we did the collapse down to just having the debug events, I felt like it may have been a little bit too much of a collapse. And the reason for that is that when we actually collate things together, we're probably adding additional stuff there, right? And so when we kind of look at what happens in sort of the debug interface stuff and that sort of thing, when we look at what goes on here, it's unclear that we really want, that this is really enough, right? This is not the thing that really stores enough information. So that collation step tends to sort of amplify the data, or at least connect data up, and want to sort of have a more complicated structure than the things that we're writing to the debug log, which are meant to be as small as possible, right? We want those to be fairly concise. And at the moment, they're actually probably bigger than we even really want them to be, because we haven't tried to do anything to make this union, say, for example, actually be more compressed so that it only takes up the amount of size it's actually using, which again is something we could do when we're writing those out. That's relatively cheap for us to do, right? So again, like I said, the debug system, this is by far the most complicated structural thing that we've done. And it's the reason that I wanted to do it is just to sort of show, and also I'm doing something that this is not the style of debug system that I've ever done before. So I just want to kind of just show how many times you tend to kind of work through these things. This is how architectural programming works. When you're trying to figure out a new architecture for something and you're not sure how it goes, you go back and forth many times on things, and you have to be willing to do that, because if you don't, you will never get to a good solution, right? You'll always kind of be stuck with sort of the basic whatever first pass thing is, and you'll never really get to the point where you kind of break through that and get to something that's better, that's on the other side, right? And so yeah, so again, I think nothing is still set in stone. It's really just a process of winnowing it down, and I kind of wanted to sort of go back and explain sort of what that means there as we go. So I don't know about that, right? I don't know if that's the right thing or not, but it just sort of seems like that's sort of where we've gone back and forth on it twice. It seems like where it sort of wants to end up is, don't try to force these two things to be the same thing when they're not actually the same thing. We're building these sort of arbitrary structures up that we want to to try to collate into more usable things that can be displayed or can be, that we can do whatever with. Maybe I'm missing something there. Maybe what I should be doing is just keeping all the debug events in a giant rolling buffer, because then it would be more efficient if you always just kind of worked out of that buffer. But maybe not, right? And so that's just kind of, I guess there's really nothing I can say about that other than it's sort of a wait and see thing. So that's where we're at the moment. And so what I want to do now is kind of go through here and start to push on this a little bit and try to get these sorts of things implemented a little bit more. One thing I will say is that when we're doing this debug record collation, one thing that's kind of interesting about it when we look at it here is, and I think this may sort of again suggest a little bit of how we move forward on this part of the design as well. One thing that I was thinking is really what we probably want to do most of the time as well is we want to be able to look at things over multiple frames, probably. Like the typical thing that you're going to want to do, for example, like especially with something like a performance counter or anything like that, or even something like a variable, just even that was a gameplay variable of some kind that had nothing to do with performance, but that just was just something that you wanted to see. If you want to look at it over time, typically you're looking at it from the standpoint of the particular quantity involved, right? And not in terms of the frame. Because usually the frame has like all this data in it, and I typically don't want to look at the whole frame. What I'm doing is I'm looking at a particular piece of code and I'm trying to debug it, or I'm trying to analyze it in some way that's important. And so I'm typically focusing on some particular part of that code, right? I'm saying, here's this variable, like let's say we're optimizing something and I'm looking at a particular performance counter or particular whatever. I want to look at that particular thing across multiple frames probably. Like I want to see like what was it, maybe like a graph over the last 64 frames or whatever it is. I want to see, where the spike was or how it was performing on average or whatever, these sorts of things. If we're talking about that sort of thing, then when we're collating debug records, as we go through here and we do this collation as we do, right? What we might want to start doing is taking anything that's a debug event that we see in here and sort of moving it out into like a list or a sort of an aggregation that's based on whichever variable it was, so that we would just have one standing structure that ends up being created that is like, here are all of the quantities or elements that the debug system is tracking, and each one of them sort of shows over time, right? And you can see the other thing being true as well, where sometimes we might want to see the things happening over time, right? So I feel like one way of conceptualizing what I think we would want to do as we try to sort of lock this down into what the final form is that we're going to be using as we go forward in the game is to think about that sort of dichotomy there, where we have these debug events, they're coming in a stream, we're trying to pull them out and put them into some sort of a structure that can be viewed in either of those two ways. So in addition to just having it be a conceptualization of like the frames that happen over time, and we can see what happened in a particular frame, it's also the concept of that way we can pick out one of these things and view it the other way. So it's kind of like a pivoting sort of a effect where we can look at it from the perspective of time or from the perspective of the element, and the other one becomes the other axis. So if we're looking at it from the perspective of time, we have the elements sort of coming across. If we're looking at it from the perspective of the elements here, it's like time going across. That sort of thing. I think that's sort of how we would want to view it, and I think we're pretty close to that. And again, that's the thing that sort of suggests to me that probably it was the right idea to stream out the events and then copy them out. But at the same time, I just don't know, because an equivalently valid way to approach this problem, I think, is to just expand the notion of the debug event to have extra space here, and then thread the debug events with that information after the fact. So the collation is just sweeping through that buffer, kind of like, placing pointer threads through the actual debug events by like, there's just space left up here or whatever, at the beginning of each debug event that's not touched. So it doesn't cost anything when the debug streaming is happening. It's just skipping over it. So it's not taking up any additional memory bandwidth during streaming. And then when collation comes through, it just threads that stuff together, right? And so I don't know. I really just don't know. And so I'm not sure. I'm not sure we're doing the right thing or the wrong thing here. It's just a really, really, really tough call, and I don't know. I do not know. But again, I'm willing to kind of like flip it again if we need to. If we decide that we're just kind of wasting time here with this additional stuff that we're doing, that's totally fine. You know, if you have to, you have to. So okay, when we were creating these frames here, you can see that sort of the frame stuff. What the main thing that we were testing out with this was the ability to sort of make this sort of thing happen, where we have all of these sort of pieces of debug information happening on the frame, right? And at the moment, those are just showing like for a particular frame. Here are the debug values that we were sort of that got announced during the frame. So if we want to kind of move forward with that, let's just kind of go ahead and finish up what we're doing there. What we need to be able to do is have some way of freeing knowing when we're supposed to free the frame. So like I was saying before, we've got to be able to free the frame here. So what I'll do is I'll find a location. I'll find a particular way where I want to start freeing the frame so we don't build up an infinite number of them. And then what we should do is as soon as we do that, we should then hit this assertion, because when it tries to free the frame, it will fail to free the frame because it'll hit this assertion that it wasn't implemented, and then we'll go implement that, right? And if we take a look just to see here, and I suppose this is probably in Handmade debug.h, if I take a look at the debug frame. By the way, I'm totally jet lagged as well, so you'll have to excuse me if I yawn during this frame. During this stream, because that'll probably happen. So anyway, if we take a look at the debug frame here, you can see that really, if we look at it, we've got these regions. The regions aren't really doing anything at the moment. That was like a holdover from our old profiler thing. But so the only thing that really has to be freed in here at the moment is the debug variable group root group, because that's the thing that sort of holds that UI situation in there. Right? And so that is the only thing that actually had to be freed. And looking at that, I would again say that it's starting to taste to me like we're gonna get close here. So what I'm envisioning, what's sort of coming up in my head that I think I was missing sort of as we were sort of working this through before, and we never quite touched on it. You know what I'm going to do? I'm going to bring up, I'm going to do it here. I'm going to bring up our mischief. Let's take a look here, blackboard.art. So wow, that loaded crazy fast. How come that loaded so fast? Normally, you guys have seen how long it takes mischief to load normally. It's all there. Weird. Is it just me, or is that kind of weird, guys? All right. Well, you know what I'm going to do? I'm going to find a new area for us to start, too. I'm going to put us right in here. Let's see here. I'm going to put us right here, maybe. I think, how big do I usually draw? I think I usually draw about that big. Would you say? Let's take a look. Let's take a look. Yeah. All right, I'm going to come in here. All right, so day 216. So I just want to kind of underscore something that I think that I wasn't overtly recognizing before, but that was sort of implicit in the system, and that was causing it was sort of preventing the design from progressing a little bit, because as we sort of played around with things and we're pushing on things, it never quite felt to me like it was quite gelling the way that I wanted to. And I think here's the part that I was sort of missing, which is that sort of the concept of like a debug, sort of I want to say a debug element, if you will, was kind of a little nebulous. And I never really articulated before that whole thing about there being time and elements and those two things being similar. So what was happening is we have a number of different things here, right? There's the debug events that happen in the log. And we know that we at least have those because that's the source of the stuff. But we don't really know anything else about them. We don't know what else they have to be. We only know that they have to dump the data that we're eventually going to display. That's really all we know, right? So we know that that's going to happen, and that's fine. But then we also have the concept of the debug UI, right? So there was also, these things are like just going into a log, and we've got them, and we don't really know much about them other than they've got sort of data in there, and, so there's just some payload, but everything else is like up in the air. What else they do, we don't know, right? We have the ability as the architects of this to decide whether they're just straight payload or whether there's actually extra stuff in there, and we've kind of gone back and forth on that a little bit, and so on. We then have the debug UI, right? And that debug UI has stuff like, hierarchies of stuff in it, where we kind of have, and sub-hierarchies and whatever. We kind of played around with that, where we have, this is a sort of a hierarchical structure. It's not like this, where it's linear. It's this kind of concept that things have parents and children and whatever, and they can be expanded and collapsed, and they can show, values in here or whatever else happens, and we could drag, we did stuff where we could drag and edit them, right? So we have that concept all in there. And then we also have the concept of actually like a debug sort of, I want to say, element, right? And this has been a little bit nebulous so far, but that's like, this piece of UI, right, is editing something, right? When we were doing that thing, like, we had, for example, in there the debug camera distance. That was something that we were able to edit, right? We had the debug camera distance, and you could drag the debug camera distance, and it would change that value in the code. And so it was like kind of a real-time way you could edit stuff, which was kind of nice. It was sort of nice to have it in there. Originally, I thought we wouldn't really need it because we have loop live code editing, but there's something nice about being able to directly change a value that might help us when we're trying to do stuff like edit some colors of things in the game. There's some merit to it, right? So if we think about this and we think about the fact that there's an element here, the UI and the element are not necessarily the same thing, right? And that's kind of a little bit confusing, but we've never really quite defined exactly what that means. And so we were sort of having this problem where, we've got these debug events and we're processing the debug events. They give rise to these debug elements, right? As we see something kind of come up in here, we're like, oh, whatever this thing is, this value, like if we see debug camera distance show up in here, oh, that's a debug element, right? But these debug elements were only existing for as long as that, stayed around. If on some frame we didn't see that, it would suddenly disappear, right? And that's a little bit wonky in the sense that what I think we actually want to do is say that these things are permanent. I suspect that's what we actually want. I suspect what we want to do is say that any time we see a debug element of some kind, it becomes a matter of permanent record, if you will, right? So when we see one of these and we see debug camera distance, I think we want to create something that is the permanent concept of the debug camera distance. And the debug UI is a transient thing that sort of looks into here and edits that, right? And so when the frame data goes away, what we actually want to go away as frames fall out of that sort of that rolling buffer is not the fact that there was a debug camera distance. I think we want that to persist. What we want instead to go away is just whatever its value was on that frame, right? So I think the thing that we actually want, right, is we actually want something which is kind of like this sort of table, right, of, we've got the debug elements here, whatever they are, and then, in here, we've sort of got the frames 0, 1, 2, 3, and whatever, and the information that we have about this element on this frame goes in here or whatever, and these columns go away, right? So in other words, my notion of what this debug element was on this frame, that will go away, but this will not. And so that element of permanence, was getting conflated. It was partially in here, it was partially in here, and partially in here, and it was like, it kind of half existed and half didn't, and who created it and when, and it was just like, we weren't sort of concrete about that. But I think, like I said, as I'm looking at this now, and perhaps this is just my brain coming back after 2 weeks and thinking it has a good idea, but it'll actually turn out that this is dumb. But there's only one way to find out. I think that's what I want to sort of congeal to, right? That's where I want this process to sort of end. I think that's what we need to do, is basically make it so that we're creating a permanent sort of structure of elements. That structure is based on what we see in the debug events. Those debug events are tracked as sort of existing over time. And as we sort of lose debug events, they fall out of sort of this tableau of sorts, right? That is, I think, the real thing that we were sort of missing. So what that suggests to me, now that I'm saying it, is that almost does sort of, that sort of starts to feel like we do want to kind of just take this simplification one step further, and maybe actually keep the debug events actually in here, not copy them, right? And so like this debug table, for example, we actually do want to make the debug table just be a giant buffer. And you know what the thing is the reason we weren't doing that because we don't have, because it has to be a static. Is that a problem for us? I don't actually know. Because we do treat it as a static here. I don't know, we could make it something that gets allocated, I suppose. I don't know, point being, yeah, we easily could make that be something that's allocated. It could actually be passed from the platform layer into the game now, because we no longer need to know those counts or those sizes. So that it may even be something that we actually would prefer to have happen. But anyway, so ignoring all that temporarily, let's just ignore that part. If we wanted to make this debug events just be a giant buffer, so whatever the memory we decide, we set aside 64 megabytes or whatever for the debug system, right? This would just be a giant buffer of 64 megabytes worth of events. And when people write events in there, they just go ahead and write them linearly and wrap, the buffer, right? So as they're sort of writing those out, then all we do during collation is basically, we thread through those events. We thread through, I want to say just basically like this tableau here. We basically said like, okay, here is a particular type of debug event that we've seen, and we thread through like, here are the values of it for every frame, right? That would basically be what we'd do. Now, the only thing that's tricky about that, and the reason that I'm like saying, well, it sort of seems like we should do that, but I'm not 100% sold on it. The reason that's a little tricky is because we don't actually know at that point when those events have gone away. Because if you imagined it just being a giant circular buffer, right, you can kind of see what I'm talking about here, hopefully. Let me go ahead and keep forgetting I should just leave this in poll position here. All right. So what I'm sort of getting at here again, and I'll just say it one more time just in case it was ambiguous, is if we have, let's just say we just have this giant 64 megabyte buffer, and here's where the debug events go. So we start off at the beginning of it, and we just write debug events in here, right? So this is, we're just writing them in. We write them in, we write them in, we write them in, we write them in, right? Eventually, some number of frames down the line, we get to the end of the buffer and we wrap back to the beginning. So now the next event like overwrites this one. So basically, event 0 was here. Event 0 is now gone, and event like, 2,450,000, I don't know what, some number here. That event goes in its place, right? So the problem is that if we were to do that, we don't know when that romping will occur. Because remember, we have multiple threads all writing to this debug buffer. They're just going nuts, right? And we don't know at what point someone will overwrite this value. So if, again, taking this example where we had like, I think we were talking about specifically the debug camera distance. So we have the debug camera distance, right? And we go like, okay, we know about debug camera distance. That's in there. When we do our collation, we saw it. It was the first thing that came in. It was event 0. It was also event like 593 or whatever, right? And so we said debug camera distance. Okay, here's the first instance of it. Here's the second instance of it, right? Here's the third instance of it, maybe, or something like that. And we've got those now. So now in the UI, we can display them. We know the 3 events and when they happened, and we can display those to the user and let them do whatever they want, blah, 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 right? Well, the problem here is at some point this one gets overwritten, but we don't know when it got overwritten, right? We have no idea. So there's not really anything that we can do to maintain the integrity of some kind of a linked list or some kind of, whatever else needs to be there, right? So, that's why I still am like a little hesitant, even though it would be more efficient to leave the debug events where they are so they don't have to be copied out into anything. If we were to copy them out, that problem solves itself because then we just have a static, stable thing where debug distance has however many frames it's saving, right, in there. And we just free them when we want to free them, and then nobody cares, right? And so again, like I say, it's something that I'm talking out loud because this is actually what I would be thinking about in my head if I were programming. I would think probably all of these thoughts. I would just hopefully think them a little bit faster than they are when I'm trying to explain them and draw them. But you can kind of see the dilemma there. And so the way that I will rationalize this to myself, because I don't necessarily know what the right answer is, so I'm trying to pick a reason why I might plausibly argue for one way or the other. I think I could make a plausible argument that we do want to do the copy out, even though it's a little less efficient, because it like basically doubles our memory traffic there. The reason that I might argue that is because I feel like we could easily get in a situation where we want to store a lot of previous values for some things and not very many previous values for other things, right? For example, the debug camera distance, we really don't need 100 frames worth of back catalog on what that value was, right? Nobody cares what that value is. It's just the debug value we use for like changing the camera to zoom in and out so that we can test, like look at like, more than just the region that the player is seeing when they're playing. That's all that does. So the chances that I'm going to need to do something like record 100 or 1,000 frames worth of what that did are like 0. That's just not going to happen. Whereas other things, like, again, performance counter kinds of stuff, that's something that may want to track a lot of hits of it over time, or certain values that sort of correspond to it. That might want to keep a lot more events in there because we're trying to do it. Furthermore, you might even say it doesn't matter what the type is, it matters what the user is paying attention to. So for example, we may want to have the ability in the debug system to do something like say, hey, when I like shift click on some a value, right, in the debug UI, when I shift click on a value in the debug UI, I want to set that debug UI value to a state where it records, infinite number of frames. I mean, not infinite, but like, thousands of frames. It just means that I'm constrained that variable right now. So go ahead and take plenty of memory and actually make sure that variable is known for a very, very long run because I'm trying to do something special with it, right? So that to me kind of is a plausible argument for why I might pick one over the other, because I'm just giving up some performance. This is the debug system, so I'm not sure I ever really care about the performance of it that much. But I can envision a feature that is more cleanly enabled here. And so that gets me out of the business of having to worry about how that threading would happen through this sort of buffer. And I can just say, I will actually do the copy out every time as we go. And so as I do the collation, I copy out into whatever sort of format we're using to sort of keep that information, right? That seems pretty plausible to me, so I'm going to go ahead and say that is the way it will go. All right, so that's good. That means that what we've got here is pretty much okay. This is a reasonable way to make this debug event system work. Just use the ping pong buffer. The events themselves will just be sort of whatever the necessary piece of information is that goes into those ping pong buffers. And then what we'll do is we'll have two additional sort of things that sit on top of it, which we sort of already have talked about. One of them and implemented one of them a bunch, which is sort of the UI elements, and we've kind of got some of that where we did like debug trees and these sort of views and that sort of stuff. We sort of worked out this a little bit, but we haven't quite gotten to the we haven't quite gotten to the part where we've actually sort of solidified that debug element part of it. And so that's the part that we'll kind of have to just finish up here in order to make this stuff work right. And because this stuff is just, it's not quite there yet, right? And you can kind of tell by the sort of the way that things are, and it's just not quite there yet. And I think that was because we were sort of missing that concrete, I hadn't quite put it into words, that concrete element that there is that concrete debug element, the concept that there is sort of this thing that exists across all the frames that sort of talks about, that talks about that particular piece of information. All right. So let's see what we can do. That's good. I feel like that kind of solidifies some stuff. It crystallizes in my head some things that we didn't really, we hadn't sort of put into words, and that were making us a little more listless than we needed to be as we were sort of trying to solidify this stuff. And you got to make sure you kind of get through all of those barriers in order to really sort of get the system architecture stuff to where it needs to be. So when we go ahead and do our free frame here, what that implies to me is that when we're doing a free frame, we're going to free kind of from the oldest to the newest frames. What that sort of implies to me is we're going to need a little bit of logic there about what does get freed and what doesn't get freed. If we want to do stuff like have things that have different sorts of lifetimes to them. I'm going to defer that part off just a little bit until I can have a little more visibility in the system. And for now, I'm just going to say, let's just say that we're not going to have, everything's going to be the same amount of time, and we'll sort of see how that breaks down. When I call free frame, the most logical point in time, I think, to try and reclaim memory by calling free frame is just if we actually go ahead and say that when we try to get new memory out of the debug arena, if we can't get it, then we call free frame, right? So basically, free frame is the thing that sort of allows us to sort of grab new memory when we need it. So what I'm going to do is I'm just going to take a quick look here for everyone who uses the debug arena. And this is a trick that I've done multiple times on Handmade Hero. I never get tired of it. It's a good one. All I'm going to do is I'm going to append an underscore to the debug arena itself so that I can go ahead and see everyone who's using it. And you can see in here, we've got basically the entirety. I told you I was going to yawn. And I did. You can see the entirety of it pretty much exists in Handmade Debug. And so that's what I would have expected. So basically all I have to do is look at all these push structs that happen on the debug arena here. And all I'm going to really have to do is make sure that all of those debug arena allocations, I'm just going to I'm going to make them happen in sort of a secondary, I'm going to insert a little step before allocation out of that arena that basically says, if you can't allocate out of this arena, let me know, because I will sort of, I'll give some memory back. I'll figure out a way to get more memory there. Now, there is something that's, I think, a little bit consternating to us, which is I think we may have had a push struct in here. Yeah, you can see right here we've sort of got this push struct in here. So inside our free list allocate, we had baked in the concept that things were calling push struct for a particular arena. And what I'd like to do is maybe say, well, I don't know if we actually want that to be the case, although I could use a function, I could use overloading here to kind of help us out, I suppose, although not necessarily with type in there the way it is. So what I'd like to do here again is make sure that this supports being able to get the allocation from a different way. And I think the way to do that, and I probably should have done it this way originally, is what we're doing right now is we're passing in the arena, but probably what we should do is pass in just the entire allocation itself, right? So what we do here is like allocation code, right? And what we do is say, like, here's the allocation code that you're actually going to call, right? That's the stuff that is what you're going to actually do there. And so if we take a look at what happens when I compile this now, and of course I guess I got to put debug arena back together, is in this excuse me, in this case, wait, what is happening? Debug event to debug event star. What did I do? Did I forget to change something? Yes, I did. Okay. Don't know why I did that. All right. So you can see now after I did that change, I'm just passing the debug arena here, but what I actually need to do is I actually need to pass the code that actually does the allocation, right? So I need to do something that looks more like this. Does that make sense? And if I compile that there, at least in theory, that should work. Oops. In theory, that should work. But I have to spell correctly. There we go. And so you can see what I did there. I just made it so I can pass in the allocation code. So that means this thing can be whatever it wants. When I look at this, I also note that now the type doesn't actually have to be passed at all. So really, this doesn't have to be there. So mostly for freelist allocate, you just need to put in what the variable you actually wanted, what the pointer was for the head, and then whatever the thing is to get new memory if it needs it. So that totally solves that problem for us, at least in theory. And here in this guy, we just need to do the exact same thing, right? So this is going to be a push struct with open debug block, right? Or at least it should. There we go. So that allows me now to say, okay, whenever I'm going to get something from this debug arena, I could instead say that instead of doing something like push struct, I could make now a way of sort of thunking through there to get stuff out of, to free stuff if I need to, if the arena is full, right? If I don't have space left and I need to get stuff out of the debug arena, I can sort of free on demand, if that makes sense. The other thing I could do, and I'm not sure I really want to do this, but you can imagine adding that to the arenas themselves. So if we thought we wanted to do that, if we thought we were going to do this sort of more generally, I could actually put it in here, right? I could put some concept of a callback in here that's like, oh, hey, you know, I don't have the memory, so please get me the memory. I don't know that I love that, so I'm going to leave that aside for now, but I wouldn't get angry at somebody who was like, I just want the memory arenas themselves to understand this and be able to handle it, right? So what I'm going to do instead, though, I just don't want to go down that route right now. And so what I want to do instead is I want to make it so that I have sort of a thunking through to the debug arena that will actually do that. And so in order to do that, what you can see in here in push size, we have an assertion, right? That assertion is the thing that tells us whether or not there's room, right? And so what I'd like to do is figure out a way to sort of make sure that I can ask the question of whether or not there's room and get the answer back without actually having to call push size, right? Alternatively, what I could do is I could actually just make this an if, and I could make push size return 0. I'm not sure which one of those I want to do. It's a really good question. And I'm not quite sure. The reason it's a little complicated is because, as you can see, the alignment offset sort of gets added to the size here. So there's actually sort of a step, an additional step that occurs. It's not just, you can't just use this assertion directly. You have to actually compute this as well. And so, you know, it's a little bit of code duplication if I do it that way. And I'm trying to think of, you know, do I want to like put it, sort of make it more complicated? I don't really know. But it would look something like this. I'd say, okay, arena has room, you know, 4 or something like that. And this would actually be exactly the same code that you would be calling, right? So you'd basically pass it the exact same thing you would pass the push size. It would do exactly the same thing. And what it would return, right, is just the result of the assertion, if that makes sense. So again, exactly the same thing, and just returns the result of that assertion. That's all it does. And when I look at it and I think about this, it looks like that's really not that big of a deal, because you could imagine doing this as well, right? You could imagine taking the memory index and going like arena, get arena effective size or something, or get effective size for something like this. So if you imagine passing these values into something, I could do this part of it pretty trivially as a separate thing and then return the size like that. And then this just becomes something pretty trivial where you have arena use plus size less than equal arena size. This size right here is just get effective size for, and we pass the arena, the size, and the alignment. All this stuff goes away. Makes sense? So that's, that seems pretty reasonable to me for the most part. I don't know, I probably was a little overzealous there. I feel like I might, during debugging, want to inspect that sort of a variable. So maybe that is a little bit, more my speed. Here you can sort of see I would just literally do that replacement. That seems, it's a little more, I like that. I like that better. I'm pretty happy with that. I would give that some thumbs up. I'm going to get rid of the default parameter here, because the only people who should be calling this are people who actually know what the alignment's supposed to be in general. And that kind of looks like maybe it's a little bit more, it's a little more kosher in my mind anyway. So at that point, what we can do is we can make a function here that would sort of be the equivalent, again, of our push size, right? It's the equivalent of this. And this is like push size with deallocation or something like that. What we'd want to do, here is do something like while, let's see, arena has room for. So while we don't have room for whatever the thing is that we're allocating, right? So here's the size, here's the alignment. And instead of passing the debug arena, what we're probably passing here is the debug state, because we've got debug free frame, or whoops, we've got free frame. We need to be able to pass the debug state in there. So this would take the debug state, and it would take these other guys, and it's essentially saying we need to do a push size. We want to push this much. Here's the alignment that we need to use for it, right? When we do this push size, and at this point we should probably also do this, because this is appearing everywhere now. Right? So when we do this kind of push size, I think I had 7 minutes left on the clock from when we started, so I'm going to use them. When I do this push size, what I'm essentially going to do is say, okay, while there isn't room for this thing, I'm going to like free frames, right? And I might also say that it's while we have room for something and there is a frame to free, we would free the frame. And then at the end of it all, right, then we would call push size, right? And we would try to allocate the memory. So at the end of it, we actually just thunk through to our, memory allocator as you might expect. And here's our result. Hopefully this is all, makes perfect sense and there's nothing particularly weird or odd about what I'm saying here. But you can see, so we've got this push size with deallocation. We're doing our push size here. What we're essentially going to do is just say, all right, we're going to keep going through here and try to free frames until we have enough memory for whatever the thing is we're allocating. Usually that would be only one frame, you know what I'm saying? Because typically after you free a frame, we'd have tons of space for whatever the thing is we're allocating. But yeah, you can see the structure of this. We're just saying if we had memory for it already, we'd never enter this while loop, so it's a non-issue. Assuming we do enter the while loop, we free the frame. Now, if for some reason we're allocating some giant thing, and this should never actually happen in the code, but if it did, and we had to free more than one frame, we could, right? Let's sit in the while loop just freeing it. But basically all we really need to fill in here in order to make this work properly and be coherent with what we actually want to occur, all we really need to know is where we get the frames from, right? So we just need some way of knowing what the most uninteresting frame is, which is really the oldest, right? And you can see we actually have that information, right? We actually scoped it. So what we can do is say, well, as long as the debug state has, an oldest frame, then we'll free that oldest frame, right? But when we do that, we probably should also make sure, right, because we're doing debug frame here, frame to free, like so. When we actually free that oldest frame, we also need to, advance this pointer because I believe frames are threaded, right? If I remember correctly how we decided to make that work. Where is, debug frame. You can see we've got our next there. So whenever we free it, we got to make the oldest frame point to the next one over. But other than that, right, it's totally fine. Now, there is one sort of a caveat here that I'll point out, which is that it's in theory possible that the most recent frame was also what the oldest frame was. So we also need to do a thing here where we say, well, if the debug state most recent frame equals the frame to free, then that also needs to be, technically it needs to do this, right? But that will presumably always be 0, because there shouldn't be anything after the most recent frame. Make sense? So that's really it. That's the entirety of it in terms of how that stuff is going to go. Now we have to make free frame actually be pre-declared, right? That's got to be up here because we're calling it. Restart collation, I believe, is gone. So that's all fine. So the last thing we need to do is actually just make a macro for this so that people can call it with sort of the convenience of push struct, which they're used to. So here it's like, instead it's going to be, debug push struct or something like that. And what that's going to do is it's going to call this. And that's it. That's really all we need to do, right? So I'm going to go ahead and sort of push through this a little bit further. Alignment offset. Alignment offset. Yeah, that's unfortunate. So I have to call that twice, which is annoying. All right, well, that's fine. Fine, it's totally fine. Don't worry about it. Don't care. Don't care. All right, so size initialize, that's a good point. Thank you for catching that, Mr. Compiler. This one is as well. Why did it not complain about that one? Was arena has room for never called? It's just because it's never called. It would have complained. Don't worry, it would have complained about that. No need to get concerned. The compiler wasn't sleeping on the job. It was doing its job. It just probably never called that because we haven't actually called debug push struct yet. Okay, so then we can just presumably just go through here and replace push struct with debug push struct, right? And then we'll just have to change the parameters to it to be debug state instead of the arena. So I believe like all of these are fine, right? What happened there? What's going on? Okay, there we go. Push struct, push struct, push struct, and that's it. So now all of those should give me a compile error, and they should give me a compile error because remember we needed this to actually pass in some different stuff. So in here, instead of passing the arena, this is actually the debug state, right? So that's got to go in there. And otherwise, everything else is kosher. So I believe all we will have to do to resolve any of these compile errors is just get rid of that sort of, finding of the arena that we were doing, right? Again, really, really straightforward what I'm doing here. Nothing particularly interesting at all. We've got a push copy. We've got a push copy, people. That's unfortunate because that means we would have to sort of also have debug push copy, which is not the greatest, right? And you can see why, like I was saying, you can see why there's some argument for building this into the arena, because then now it's like, okay, we wanted to use push copy, and then you have to have a copy of push copy as well, which is kind of annoying, right? So that, that makes me reconsider that. That makes me think, well, maybe I should just take this guy right here and put it in. I don't know. It's got some merit. I'm not gonna lie. Definitely does. So yeah, let's just think about that for tomorrow. Just keep that in mind. And I don't know, maybe we'll talk about it in the Q&A a little bit. So yeah, okay, so we've got a push copy when push copy comes to shove. So we've got a debug push copy and debug push struct. Yeah. Let's see how we're doing here. Debug state. Undeclared identifier. Is that so? Yeah, that is actually so. Here we go. And hopefully that's the last one. Yeah, see? Happened again. Right? So that actually does kind of make me want to build it in. Just looking at how many times we were using that, that just does, that really does make me kind of go like, okay, that's troubling. These are just graphics calls. Debug push struct. Let's see, push rect. Debug push struct. Debug push struct. Push struct, debug push copy. Push struct. Push array. Push font. So yeah, so I think that argues pretty strongly for it, I guess is what I'd say. Because I don't think we want to be in the business of duplicating all of these. It's just not, that's just not a useful thing for us to be doing. And there could be plenty more of that down the road, right? There's no reason to think that it wouldn't potentially proliferate. So yeah, so I don't love that. But there we go. That's all we really need to do, regardless. And so now, in theory, we should get to a point where we actually, yeah, there we go. We should get to a point where we run out of memory and we try to free a variable group and we get to our not implemented. So that's what we wanted and that's what we got, and that's good. But I think what we want to do is just, put a to-do here that's like move this into the arenas proper so that everything doesn't have to be duplicated. So that all the macros and utilities don't have to be duplicated. And so there's, like I said, there's a few downsides to that, right? It's not all positive, but maybe we'll address that tomorrow. All right, that's about it for now. We're out of time, so let's go ahead and go to the questions and answers, right? Let's just Q&A. If anyone has a question of what I was talking about today, and we'll see. Let's see. Have you heard of the dtrace tool? It allows dynamic tracing on running binaries and also kernel. Not available on Windows, though. No, I don't think I have. I mean, I mostly develop on Windows, so I don't tend to know much about the Linux utilities, to be honest. Elvin, you mentioned in the pre-stream a dynamic memory arena. How does that actually work since we allocate memory only once? What happens when the arena is full? So all you do is you just make it so that you allocate in chunks. So you allocate, like I said, like 256 meg at a time or something, or 64 megs at a time, or however much you want at a time. And you just go back to the operating system and get more memory. If you want a dynamic arena, right, there's nothing, pretty much everything we've done, you can actually do with dynamic memory allocation as well. All you have to do is just take the arenas, and when they run out of memory, they just ask the operating system for more, right? So I was just trying to point out that, like, at some point I may show how to do that because it's very simple, and it, people get confused sometimes about the static allocation nature of things, and it's just like the code actually, all the code we've written doesn't actually have to change at all. It can actually work exactly the same with almost no modification, and so that was just something I was mentioning. Mojo123x, you've mentioned the term collation in this episode and several previous episodes. What exactly do you mean when you use that term? What I mean is that the way the debug system is set up right now is all of the game and engine code writes debug events into a buffer, and those debug events are totally raw. They're like, I entered a timing region and I exited a timing region, right? But at no point does anyone know how long we actually spent in that region. So then, after the fact, the collation part is going back through that buffer and going, oh, I see a start and an end event. I'm going to like pair those up together, take the difference between their clock values, and produce like the actual amount of time that was spent there. That's like, it's like collating, like there's putting the things in order and understanding what they mean or whatever, right? What keyboard do you use? This keyboard right here is a DOS Keyboard 3. My current favorite keyboard is actually the Razer Stealth Tournament Edition. That's what I have on my other computer in the other room. Could you elaborate a bit more on what memory alignment means? Not probably right now, because that was a whole, we talked about that back in the episode where we talked about memory alignment. Basically, it just means, the memory address that you're actually talking about, right? A pointer, or everything's stored in memory somewhere, right? So a pointer is like an address in memory. It's like where stuff is stored. Basically, certain operations on certain CPUs require those addresses to be aligned to a certain boundary. So, for example, if you had the address 16, the 16th byte in memory, it might be valid to do an operation on this 16th byte in memory. But it might not be valid to try to do that same operation on the 13th byte in memory. And the reason for that might be that the alignment that's required by the processor is 16 byte boundaries, which is to say that the actual like pointers have to be aligned every 16, right? So if I wanted to talk about a certain value as far as the processor is concerned, it might just be like, okay, it's got to be either at 0, 16, 32, 48, 64. It's got to be at one of those locations. It can't be in between. It can't be like off of that alignment. That's what memory alignment is. But that's a very brief explanation. We talk about that a bunch in earlier episodes, so you'd want to go back and look at that. Elvin, but wouldn't asking the OS for more memory expose more failure points, and thus against the HMH memory philosophy, since the whole point of our scheme was that we're sure once we run the game we can't crash? Well, yeah, like I said, I don't expect that we will necessarily do that, meaning I don't know that we will use dynamic arenas for the actual game storage. But a lot of people ask questions about it, and it's really trivial to show how to do. And it's conceivable that you could ship the game with it that way. And it would basically just be like, okay, if there was a dial that the user can set for how big you want the game world to be, and we're like, well, we let you set that to as big as doesn't crash your machine or something. You could see doing that. I don't know. I don't think I probably will do that, but I'm just saying, we could. I just kind of wanted to get across the fact that you don't have to take my memory philosophy, right? Let's say you want your stuff to just dynamically grow, and if it crashes, it crashes. That's what you want your thing to do. The point is just that decision doesn't change the rest of the code we wrote. You still could write it exactly the same way, and I probably would, right? So the two aspects there, the fact that the fact that we may want to allocate a big block of memory and then run and know that we never would crash or run out of memory, that fact doesn't actually change. If we were to change that decision, it doesn't actually change the rest of the code. All the rest of the code stays exactly the same for the most part, and that's the important part. Elvin, I'm always hesitant when using linked lists in engine code and gameplay code because of their cache unfriendliness, random access of memory, and difficulty in debugging. You'd have to dig down a node to find what you're looking for. Do you think it's not that big of a deal and I'm worrying too much? Well, I guess what I would say is, yes, you probably are worrying too much, but no, you don't want to completely unworry about it, is I guess what I'd say. In general, like, places in the code that might be hitting pretty heavy, that might take a significant amount of the execution time in general, probably don't want to be using linked lists that much, depending on the circumstance. Now, sometimes you do, right? Sometimes linked lists are the best thing, etc. So you don't want to design your system in such a way that you have to use linked lists somewhere, or that the whole thing depends on it being linked lists, because then when you profile the game and find out that something is slow, and then go, oh, the reason it's slow is because it's a linked list, and it's like, too cache unfriendly, and we need to make this an array or some kind of, thing like that. You have all this work you have to now do to fix that. That could be a problem. But as long as you're using, if you're just using linked lists in a way that would be easy for you to replace at any time with something else, then I wouldn't even really be worried about that, because, as long as it's free, as long as it's reasonably simple for you to just go, I see there's a performance problem here, so I changed it from a linked list to something more efficient, that seems a totally fine thing, right? On the other hand, I would also point out that the concept that linked lists are slow, you actually have to understand where the slowness might be coming from, or whether it actually affects you. Because one of the reasons that people might see linked lists as being slower than they actually are is that if in general you're allocating them very sparsely, then you're pulling in a different cache line every time, and that can make them be very slow. But if you allocate them out of an area where they're all together already anyway, it may be that they're actually not that slow, because they're all kind of actually fairly cache coherent, right? And the way that we do the memory arenas, a lot of times you will be allocating linked lists right next to each other potentially. So there's other reasons why linked lists might not be as cache unfriendly, depending on how you actually do them. And so that's a sort of separate issue, but not really that related. In general, I would just say the takeaway is always be aware of what the cost will be for you to change whatever the thing is you're doing. If it turns out to be a performance problem, that's a very good way to think about it, because it lets you know as you're going through the code when you need to make performance decisions. And so if you get to a piece of the code and you go, it would be expensive here for me to change the way that I'm storing these things, that's a time to usually go, okay, I should probably stop and figure out what would be a good performance oriented storage mechanism and implement that from the start rather than just doing whatever is most expedient. But in most cases, doing what's most expedient is actually probably the best thing to do first, and then come back to it later when you're actually able to measure the performance. And if there is a problem at that point, now you have actual metrics now to work with and know what you're actually trying to do, rather than guessing what you should be doing, and whether a linked list or an array or a hash table or whatever is better there, right? Jim00 says, I'm debugging on day 121. Do you use int instead of int32 for any reason? I might have. It depends what the circumstance was. Most of the time, I don't use something like that. Oh, this is going to be hard, right? Because it's going to show me all the ints. Yeah, this is bad. Yeah, so looking through the code here, like for example, this is not, I don't know why that's an int, right? Like that should probably be a uint32. I would say this one should probably be uint32. Those are probably should not be there. Test sine wave, that's just some test code, so I wouldn't really care about that too much. Int depth and handmade debug, I don't know why. Yeah, so these, those are just oversights. We really shouldn't be using ints, I feel like, in most of these cases. Yeah. Yeah, I don't know. I don't know why we're using ints in these. I would say that's just an oversight. I don't know why we're using ints in those cases. We could probably replace them, and probably should eventually. And SZ, libs like the SDB libs let you specify a custom malloc free function. How would you integrate that into an arena-based system? Well, I guess it depends on what you mean by integrate into. If you're trying to say, how do we actually get the memory out for them? Well, you know what, honestly, I guess I'm not sure what you mean. What do you mean by that? Would be my like what do you mean by how do you integrate into it? Are you saying are you basically saying if you have an arena-based system that you're using, and then you are trying to call the SDB library to do something, how do you specify malloc and free to it? Is that what you're saying, I guess? Elvin, have you heard of vmem? No, I have not heard of vmem. Elvin, if we wanted to use object pools, reusable, recyclable objects for enemies, for example, where would be the best place to store them, permanent or transient memory? I guess they wouldn't be in transient because the whole game shares the same pool, so I guess permanent. Yeah, anything, permanent and transient is just about whether or not it's something that could be regenerated if you got rid of it, right? And so the transient storage is just things that if you blew it away, it could just be recreated on the next frame. And it would be slower to do that because it's where all the stuff gets cached, like bitmaps and everything. So you don't want to throw it away, but if you did throw it away, it was fine. Permanent storage is where you store stuff that actually is the state of the game and can't go away, right? Meaning if you deleted the permanent store, then you lost your game state. So the user just lost whatever the game was that they were playing. So the permanent store, that needs to stay there. Elvin, reinterpret static cast and dynamic cast. Are they of any good use? Not really. There's I guess Not, I mean, not really. Not that I can think of offhand. They're just kind of extra verbosity for no real reason. I mean, yeah, I would say no. They're pretty useless. And a C. There are libs that allocating and freeing multiple chunks of memory during runtime. How would you specify malloc free for them in an arena-based game like Handmade Hero? You can't, really. I mean, basically, if you have a system that requires fully dynamic memory allocation, then there's no way you can use it in a system which is not about fully dynamic memory allocation, right? Now, for certain circumstances, you can just ignore it. Like, for example, if you know that there's a bounded amount of memory the thing will use, you can just not have free do anything, and you can have malloc just be push size, and then when you're done calling through the library, you just get rid of all the memory, right? You use the like temporary memory point thing that we did. So, you know, you can do that if you want to. But yeah, you can't integrate those in. It's one of the reasons I don't really like using most libraries is they don't have a solid memory model most of the time. So they don't really let you give them efficient ways to deal with memory. They always just expect fully dynamic memory, which is usually not necessary. I mean, if you actually look at what the library actually needs, it doesn't usually actually need fully dynamic memory. It usually needs like 2 stacks, one for stuff that's going to keep, and then a temporary stack. That's usually all it needs. But, you know, what are you going to do? Jim0000, the int used in question was a lot in SIMD draw rectangle today, and my version of the code is crashing on access violation reading location when casting pixel to M128i at the start. Could iterating with int versus int 32 meters and no. Although that sounds to me like an alignment problem, memory alignment problem, but I don't actually know. It could also be because the source memory is not there, but I don't know. But no, that has nothing to do with int versus int32, I would suspect. Because int and int32 are the same thing. So there's really no difference between typing either of those. What do you think of pass by reference and references? I think they obfuscate the code because it's harder now to see from the calling site to find out if an object is passed by value or are we actually passing an address of it to modify it. I guess what I would say is references, like everything else in C++, were like a they were like somebody who didn't really know how to program, was like, I should probably try to do something that fixes this thing. And then they made something that didn't really actually fix the thing, right? And what I mean by that is so there actually is one useful thing about references, and that is that they allow you to use the semantics of something as if you actually had it, even though it's actually a pointer, right? And the reason that's kind of nice is because it gets you to be able to do stuff like this, right? It's like, okay, I write some code, and I'm like, you know, I do some stuff where it's like foo.x equals, you know, bar.x plus, you know, something, whatever, I don't know, this sort of thing, right? And then later on I decide I'm going to pull this out into a helper function, so I copy the thing, but I need to pass the foo that it's operating on, so now I have to change it to a pointer, right? That sort of thing happens. And so this gets annoying when there's like tons of these, right? And now like I copy them up in here and it's like, ah, crap, I gotta like change these all to like the thing, right? It's just annoying. And so being able to do this was actually kind of nice, because it means that like when I call this thing, now the code is the same, even though I'm trying to do this like concept. I'm trying to do this like I'm passing you a thing that I want you to modify, so I'm not trying to pass it by value, right? The problem is, and this is not really necessarily the thing that they were trying to solve with references either, mind you. This is why I say that, like, you know, original C++ design is just all messed up. But the thing about this is it's actually just papering over the thing you actually wanted, which is to not have dot and arrow in the first place. Like, what I actually wanted is to just have this code just be the same in both cases, right? Because it is basically the same. You know, the compiler doesn't need this information. In fact, there's never such a thing as code that can compile like this and this at the same time. So the compiler always goes, oh, it's a pointer, it needed an arrow. It could have just gone like, when it's a pointer, I use the dot as well. And that would have been a much better use of that, right? So yeah. So I don't really like references. They do have one nice aspect, I guess, but still. All right, looks like we don't have any more questions. So I will go ahead and sort of wind it down like a little like wind-up toy that has run out of spring, if you know what I'm saying. So thank you everyone for joining me for another episode of Handmade Hero. It's good to be back. I hope you have all sort of gotten your programming sensibilities back on track for this week of coding. I will be back here tomorrow, 5 p.m. Pacific Standard Time again. Hope to see you all back here on Twitch. And I guess I should also point out the fact that it's a slightly short week. We didn't have Programming Monday, but we'll be programming Tuesday through Friday. So, and then we'll pretty much be back on regular schedule for the rest of the time, I think. I don't know what we'll be doing about Thanksgiving, but maybe we'll be off just Thanksgiving Day. I'm not sure. But in general, we should have a regular schedule from here till the holidays, till Christmas time. All right. That's about it. As always, if you want to follow along at home, you can always pre-order the game on handmadehero.org. It comes with a source code, and so if you would like to actually play around with it yourself, that's an easy way to do it. We also have a forum site, which has now been taken over by the Handmade dev guys, so it's hosted on their site, and it seems to be running pretty smoothly now. You can see it's now at hero.handmadedev.org. And it's still kind of, you know, being worked on, so there might be some transition pains, as you can kind of see as it's kind of imported. But it seems like it's working pretty well, and should be fully functional. If it's not, always let us know. The folks who are working on it are pretty darn good, and they manage to deal with Joomla nightmares and all these other sorts of things pretty quickly. So if you report a bug, it tends to get fixed presently. We also have a Patreon page if you want to support the video series. We have a tweet bot that tweets the schedule at you. So if you want to know when the series is going to be live, that's also a good place to do it. We also have a convention coming up. There's, I think, something like 25 tickets left, I think, at this point. So it's almost sold out. But if you would like to come to our convention, it's in Seattle. It's coming up in just, what is it? It's coming up, it's right here. So it's just like, it's a little over 2 weeks away, 2.5 weeks away, let's say. There's still a chance to get some tickets to it. So if you type handmadecon.org into your browser, you can go to the site that has the tickets on it, and there are still some available. So, again, hope to see you guys back here tomorrow, and of course, hope to see you at HandmadeCon in December. Until either or both of those things, have fun programming, and I will see you guys on the internet. Take it easy, everyone.